So hello and welcome back everyone. In this video we are going to discuss the problem D of today's contest, which is XOR construction. So you are given an array A of n-1 integers from A1 to an-1, and your task is to construct array B of length n such that every integer from 0 to n-1 should appear in array B exactly once, and for every I from 1 to n-1, a of I should be equal to XOR of bi and bi plus 1. So let us see how we can solve this problem. So you are given array A and you are only given integers from a1 to an minus 1, and the value of a1 should be equal to XOR of b1 and b2. a2 should be equal to XOR of b2 and b3. Likewise, an minus 1 should be XOR of bn minus 1 and bn. So instead of taking integers from a1 to an minus 1, let us take integers from a2 to an for simplicity. So a2 will be XOR of b1 and b2, a3 will be XOR of b2 and b3. Likewise, an will be XOR of bn minus 1 and bn. Okay, so let us try to take a simple example where we have only binary numbers, and these are the bitwise representation of the numbers, right? So we are given four numbers where n is 5, and these are the bitwise representation of a2 to a5, which is 101 and 1. So you can see that for a particular fixed value of b, the rest value will be also get fixed. Like if this is a bitwise representation, then there are only two particular values to have in this place. So it can have either 0 or it can have either 1. So the remaining values can be set by having this condition, which is a2 should be equal to XOR of b1 and b2. So what should be value of b2 to make XOR between b1 and b2 equal to a2? So we can have b2 equal to 1. Likewise, we can make b3 equal to 0, b4 equal to 1, and b5 equal to 0. Similarly, if we have 1 at the starting place, we can have the rest values as this. So we have two particular options, either to take this particular sequence, this particular bit, or to take this particular sequence. So see that you are given that b should be have all values from 0 to n minus 1. In this particular case, b should have all values from 0 to n minus 1, that is 4. So we know that bitwise representation of the numbers are nothing but 0, 1, 2, 3, 4, and its last bit will have representation as 0, 1, 0, 1, 0, 1. So you can see that total number of zeros are greater than total number of ones. If we have another number like 5, it will have another one. So number of zeros are always greater than or equal to number of ones. So you can use this particular observation here. So in this particular sequence, the number of zeros were 3, but in the second sequence, number of zeros were 2 and number of ones were 3. So this is not the accepted sequence, and this is a particular correct sequence which has total number of zeros is greater than or equal to total number of ones. As it is a consecutive numbers, so it will always have this particular pattern where total number of zeros will be always greater than or equal to total number of ones. So you can use this particular strategy for every bit and calculate its bitwise value. So let us take another number. So extending this particular example to two digit or 2 bits, suppose we have additional bit like 1, 1, 0 and 0. So again we have two options at the first place of the second bit, either to take 0 or either to take 1. So the last bit was set. So here also we have two options, either to take 0 or either to take 1. So if we take 0, what will be the rest of the values in this bit? It will be 1, this will be 0, this will be 0, will be 0. How we are calculating it? We are just taking XOR between this number and this number and calculating it, because XOR of B1 and B2 should be equal to A2. So B2 is nothing but XOR of B1 and A2. So I meant to say that A2 is equal to XOR of B1 and B2. We know B1 and A2. So B2 will be XOR of A2 and B1. So this is property of XOR. So again you can find, if we have 1 at the first place of B1, what will be the rest values? So this will be nothing but XOR of this bit, XOR of this bit with the XOR of this bit. So it will have value equal to 0. Now again we will have XOR of this number with XOR of this number. So we will have value equal to 1. Again we will continue this particular procedure for the rest of the numbers. So this will have value 1, and if we take XOR of these two, it will have value equal to 0, a value equal to 1. Now you can find that when we have taken the starting bit as 1, total number of zeros were 0 and total number of ones were 4. But when we have taken starting bit as 0, the total number of zeros were 4. So total number of zeros were 4 and total number of ones were 1. So this is the correct way, because total number of zeros is always greater than total number of ones. So this is the correct sequence which we can return. So for every bit you can try this particular strategy and find what is the correct sequence which is satisfying the condition. Okay, so that was the particular intuition of the problem. I will show you how I have implemented this. So this is a simple code. I have taken the vector v and I have taken all the input from 1 to n minus 1. Notice here that I haven't taken input from 0 to n minus 2. After that, for every bit I am calculating what will be the value of each bit in the answer. So z is representing the total number of zeros we are having. So we have first considered that the first bit we have considered as 0, and now we are calculating the XOR with every number and incrementing it whenever we are having 0. Now when we are having the first condition and we are satisfying the condition is that total number of zeros are greater than equal to total number of ones, so we are setting the first bit as 0 and incrementing the numbers whenever we are having set bits. Otherwise, when this condition is not satisfied, then setting the first bit as 1 and then changing all the rest values, and whenever we are having the set bit we are incrementing answer by that particular value, and at last we are printing the number. So this was the solution to the problem. I hope you like the presentation. If you have any doubt you can ask me in the comment section. Thank you so much.